because the chemical reaction that's happening, oh, this is exciting, is now the H3O plus from an acid reacts with the OH from a base. Okay. All right, so the reaction between an acid and a base produces always an ionic compound and water. Always. Sometimes, like in textbooks and stuff, instead of saying an ionic compound, it will just say a salt. So write that in your notes. Ionic compound, in some contexts, is just called a salt. Because in very simplistic terms, ionic compounds are salt. Okay? Even though you know that salt in its definition is NaCl. But in a very broad sense, ionic compounds are salts. Okay, so think about it. Acid plus a base gives you a salt plus water. See? Told you. Okay. I'm excited about neutralizations. Whatever. Okay, so for example, let's say we have HCl plus KOH. So think about it as a double replacement reaction. Okay? So think about it like this. This is like the positive ion, the negative ion. The positive ion, the negative ion. So this one and this one hook up. This one and this one hook up. Okay? We're going on a double date and we're switching. Don't do that in real life. Okay? So we make KCl that will be dissolvable. And then we're going to make HOH, which we know is water, so write that as a liquid. Okay, write it as a liquid, not as aqueous, because the definition of aqueous is dissolved in water, so it's redundant to say aqueous, okay? The products of neutralization are both what? What do you think? I'm not coming out until you say it. Basic, acidic, or neutral? Neutral? Yes. It's a neutralization, right? If I'm neutralizing something, I'm making it neutral. Water is neutral, salts are neutral. Yeah? Yeah, isn't that exciting? So, yeah, that's what happens, okay? Now, in a neutralization reaction, or we just can call it an acid-base reaction, okay? Because neutralization means putting an acid and a base together. Between a strong acid and a strong base, the product is always water and a salt. Okay? But let's think about it. What if I had a strong acid, or no, let's say a weak acid, like vinegar, and I added sodium hydroxide to it? What do you think would happen? Like if it was a really weak acid plus a really strong base, what would happen? Would it be totally neutral after? It might be more basic, depending how much I added, right? Like say I had a huge flask of vinegar and I just added a drop of strong sodium hydroxide, it might just totally neutralize. But if I added in the same volume of a strong base, I would get an overly basic solution left over, right? So you kind of need to think about that. Even though a neutralization is happening, you need to think about the quantity of what you put in and how strong it is. So here, sorry, just put in. What we actually have happening, now that we know about acids and what they really are, we have H3O plus reacts with the OH minus. And it will make 2 water molecules. So this is the chemical reaction that's happening. If we took out all of the spectator ions, okay, I'm connecting stuff from solutions. You should write this stuff in when I'm saying these things. If I took out all of the spectator ions, this is the chemical reaction that's actually taking place. Remember when we were doing our net ionic equations and there was an acid plus a base and you didn't know which ones to take out and stuff? And I said, okay, well look at what's happening here. We have an acid plus a base. So that liquid, is different. Once it becomes this water, it doesn't break up into ion form. So this is what's different. But now since you know about acids, it's not just H+, it's H3O+. Now, how do we apply this to normal life? Well, due to their reactivity and corrosiveness, acids and bases need special care. And they must be used when they are being produced and transported. So sometimes people think about acids as being like the really bad things, but bases can be very corrosive and bad too, like very destructive. So don't be fooled by the bases. They can be just as nasty. Never mind. Okay, so two ways to deal with an acid or a base spill. So if you have an acid that's spilled, how to deal with it? To dilute it. So reduce the concentration by adding. What do you add to a dilution? Water. Or you can neutralize it. So if we spilled some acid and we needed to clean it up, it's kind of a bad idea to just clean it up with a paper towel, Like you would want to do something to that acid first so that it's not as harmful. So diluting it and then sopping it up, or neutralizing it. So you could use a weak acid or a base for the neutralization. So you aren't left. But I wouldn't want to add a really strong acid or a really strong base, because now I have an acid or base spill, and you're just adding to the problem. Okay? So this is actually, it's kind of cool, because this is just a mini introduction to what we're going to investigate in Chem 30 about acids and bases. So it's just like a little snippet at looking at the weak and the strong acids and bases.